DevOps. Auf die Ohren und ins Hirn. Ein Podcast rund um DevOps.
Von Luca Ingianni
und Dirk Söllner.
Welcome to a new episode of DevOps auf die Ohren und ins Hirn, or in English, DevOps from your ears straight to your brain. Usually this is a German language podcast, but we sometimes make exceptions for international guests. Today is one such exception. My name is Luca Ingianni and I host this podcast together with my colleague Dirk Söllner. We're both DevOps consultants, trainers and coaches, trying to get teams to work together better and create better products for their customers. Today we're joined by Jeff Gable. Jeff is an embedded software consultant for the medical device industry, and his mission is to drag medical device software development kicking and screaming into the 21st century. Jeff, welcome to the show.
Hi, Luca. Hi, Dirk. It's great to be here. Thank you.
Hi, Jeff. Great to have you here. I want to give you a warm welcome.
Thank you.
Could you please give us a short impression to introduce you? How would you introduce yourself?
Sure. So as Lucas said, I'm an embedded software consultant, and I'm focused on the medical device industry. And the medical device industry in general is way behind the times in terms of adopting modern software development techniques and principles. And so it's, as Lucas said, it's my mission to drag the medical device industry kicking and screaming into the 21st century. I'm trying to introduce agile software techniques, DevOps principles, and starting at the technical level and moving up the organizational level. I've been a solo consultant for 3 years, and it's been a fun journey.
Awesome. Since you spoke about DevOps, we usually have this tradition on the podcast of having our guests explain to us their definition of DevOps. So what's yours?
Sure. So DevOps is obviously the amalgamation of development and operations. And I think at its most fundamental level, it's about breaking down the silos and treating the production of a software product in a more system with a system level view in a more holistic way, as opposed to the way it was done before DevOps was introduced, which was in a very siloed way. And there's certainly, there's lots of other principles that come along with it, but I think that's the most fundamental level for me, at least.
Okay. Are there some difference between DevOps in your industry and the normal industry for Luca and me?
Sure. So my understanding is you guys are focused in the web development world, and my focus is in the embedded device world. And I'm not an experienced web developer. I've done some, but I'll say the two most obvious differences to me are, one, in embedded systems, there's hardware involved, and hardware is just trickier to do in an agile context. The iteration time is fundamentally slower. Luke and I have talked about this on our own podcast, that there are ways to speed that up. But fundamentally, hardware adds this complication that just isn't there in the world of web development. And the other thing is that maybe because of this hardware and because these things have been slower, these principles have been slower to be adopted in the embedded development industry, the tooling is 10 years behind, at least. And in the medical device industry, I would say even more, like 15, 20 years behind, where it is in the web development world. And so newcomers to the industry, or those in the industry who say, we're not doing this well, we want to be more agile, we want to start doing this in a more modern way, they don't have that really mature set of tooling and practices that they can just draw from. They have to figure out a lot of things along the way and cut themselves on a lot of hard edges. And so that those two things, I think, the fact that hardware has a slower iteration time and the fact that the tooling is less mature are the two main differences.
Yeah, I was just going to ask, what are you even doing on this podcast? You're doing hardware, aren't you? How does that, does DevOps even apply? to your line of work?
Absolutely. So I am not a hardware engineer myself. I'm a software engineer. So I write embedded software and firmware, and so very, very much I try to apply DevOps principles in my daily work and convince the others around me to do the same. But it can be an uphill climb.
How so? Like, why is it hard to convince people to do DevOps in hardware?
Because essentially it requires a different architecture, maybe in terms of how you actually write the software. So you can't just take kind of a traditional embedded software application that was written without this in mind and just kind of do DevOps on it. Like there's, in order to even take the most fundamental technical steps, like setting up a continuous integration server, doing automated builds, starting to do unit testing, your application has to be architected in a way that supports that. And that's often not the case for someone who didn't write an application with that in mind. So it often, especially if you come into a legacy program where there's a lot of code built up, it's really hard even to take that very first step. And that's if you're motivated to do so. A lot of people just don't really get it and don't understand the value in it. And so that's where it just takes longer to convince them. You have to do those architectural changes yourself, get it going, start to demonstrate some benefits before people really see the value in it.
Okay, let me ask about this again, just because you pointed out that iteration speeds are slower, everything's maybe more complicated and clunkier. Can you even reap the benefits of agile development and of DevOps in especially maybe in safety critical industries like medical devices or something? Or are you just fundamentally shackled to maybe half-year or yearly release cycles and you really have no chance to iterate quickly as Agile would want you to do?
Sure. So again, because my focus is in embedded software and because I've architected my software to be as divorced from the hardware as is practical, my software development definitely takes advantage of Agile principles, and I can iterate very quickly. I think if you look at it, so you can have kind of an Agile software department within a organization that is not Agile, and maybe you guys have touched on this in the past, where if some of your audience, they're a mid-level software manager, say, and they want to start making things better, but they're stuck in this organization that is, say, more waterfall driven, you can still do a lot within the area over which you have control. You just can't, maybe the organization will never come along the way you would like it to, but you can still get a lot done in your own department. And so in my sense, even if I'm working with a medical device company and the hardware releases are 6 months apart, I can still do lots of software iteration in the meantime. And I can even get the software ahead of the hardware and demonstrate that it's working in simulation or emulation, and then inform the hardware what changes they need to make. Encouraging them to do it more quickly, that can be more of a challenge.
So in the end, I suppose it comes down to that principle that we talk about in quote unquote ordinary DevOps as well, which is autonomy, right? You need to be sort of insulated from the hardware, and conversely, I suppose, the hardware from you, so that everybody can move along at their own pace. Would that be the right kind of understanding?
Sure, I think that's a really good way to put it. Certainly, the software needs to be insulated from the hardware. I haven't really considered whether the hardware needs to be insulated from the software in that way. I suppose in the sense that the hardware team should get input from the software engineers, obviously, but they should not feel constrained from making a change because it will cause problems in the software. And that's where actually having a good software architecture that's decoupled and divorced from the hardware should be able to change out from under you as the software developer, and it shouldn't cause you a lot of problems. And that because you've architected your software in that way, now the hardware team is free to change things more rapidly. if they find a new sensor or new component that has better performance, no longer is it going to be, well, don't change that because the software can't support it, or it'll take forever in software to write a new driver for that. So yes, actually, I think it works in both ways. It helps both the hardware team and the software team to have that good software architecture that minimizes the dependence between the two.
Very interesting. So even though maybe the circumstances changed, all the underlying principles are, just as applicable, aren't they?
Right. I mean, if you look at, kind of Gene Kim's 3 ways of DevOps and looking at things from a systems perspective to try to move increase the speed of the flow of work through the system all the way to the end, increasing the speed of the feedback loops to get information back upstream, and practicing continuous improvement. Those 3 principles are valid in almost any context, and the way you apply them may differ, but I absolutely think those principles are just useful in any context.
You said that embedded is 10, 15, maybe 20 years behind the times. What does that mean for the practical work of developers or engineers?
Right. So it means that essentially, if you want to take this agile transformation journey as an embedded developer, there are not as many best practices figured out for you. You're going, like I said, you're going to cut yourself on some sharp edges of the tooling. The tooling in particular, there are starting to be services coming online that I think will provide a lot of power and utility and take care of a lot of the really messy details. Services that come to mind, Memfault, which makes remote monitoring and debugging very easy. Platform.io, which is just a general embedded IoT platform, takes care of a lot of the cloud service details for you, and over-the-air updates, that kind of thing. Renode is a very good emulation platform, rather, that makes that much easier. It's kind of Docker for embedded emulation. Docker is now, how old is Docker? 10 years?
I guess so.
Right. So Docker is
behind.
Exactly. And again, because I am not an experienced web developer, maybe I say the word Docker and that already dates me. So Luca's nodding his head yes. So anyway, so and even maybe in the web development world, I'm sure there's a lot of controversy on the bleeding edge. People are really into Kubernetes and other people are very anti-Kubernetes, whatever. The point is that industry has progressed really to the next level in terms of enabling smaller development teams to accomplish more and more. And that is just now, and that's been the case for a long time in the web development world, that's really just now coming online in the embedded world. And so it's an exciting time in the embedded development world because all of these services are just now becoming available and getting mature. But even so, simply setting up a continuous integration server, a lot of it is built for web development, and to apply it to embedded development just takes a lot of fiddling and configuring, and you have integrated development environments and debuggers that are designed to work with the hardware, and it's hard to get the USB connection to your sandboxed thing. So it's that's what I'm saying is the practical different effect on the day-to-day work is that there's going to be a lot more. An embedded developer will have to figure a lot of these things out on their own.
Okay. Jeff, you're talking about difference between embedded and web development, and you said tooling is 10 years behind. What about culture? What about culture?
Absolutely. The culture is the same way. Especially in the regulated industries. So where I come from, medical devices, and I'm certain, aerospace, automotive, nuclear power plant development, that kind of thing. They're going to be even farther. So I haven't actually done very many consumer electronic projects. So I would imagine that's a little more stratified in terms of there are still people doing consumer electronics that have no idea. And there are people doing consumer electronics who are quite modern and are taking advantage of all of these services that I just mentioned or developing themselves. So the culture of these organizations, I think is also very behind. Again, there's a bit of that chicken and egg problem. Like if you want to change the culture, you've got to show the benefits, which means you've got to like actually accomplish the technical tasks, and the tooling makes that difficult, which means you don't have anything to show for it, which means it's hard to change the culture.
So on and so on and so on.
And so on and so on and so on. So you have to be a source of excellence and just drive your organization forward in whatever way you can.
Regarding the silos, hardware
Yes.
and software, what do you think, or do you know some teams which are cross-functional, so where you develop the hardware and the software within one team?
Yes, and in the medical device world, there are a lot of startups where it's basically just a few people. So it's really the entire company is only a few people. It's all one product team working on one product. And so in such companies, the electrical engineer and the firmware developer are going to be sitting very close to each other. And what you would hope from a cultural perspective is they're extremely collaborative. The classic interaction is they're both blaming each other the problems. I think it's in hardware. No, I think it's in software. That really doesn't happen quite as often as you might fear. But I guess that's something I like to make sure to practice. And especially with my background, my degrees are actually in mechanical engineering, and I've done, I haven't designed any PCBs, but I've done a lot of PCB schematic review. And so, everyone having to, and then again, I've tried to teach software skills to my EE and ME counterparts so that they at least understand a little bit of my world. So certainly the more you can do to infuse the skill sets, that will also help to infuse the mindset and add some empathy and enable you to be more cross-functional.
Yeah, but I'm not sure whether that mirrors your experience. Like, I've often experienced that, even though everybody's meaning well and trying really hard to work together and be cross-functional, especially like mechanical engineers and software engineers come from very different worlds in terms of like their traditions, even of maybe expressing technical ideas. How much of a stumbling block has that been for you?
I think it is a stumbling block in the industry. I can't speak to it that intelligently just because I happen to have that cross-functional background. That's my own personal engineering background. And most of my work is with small teams. But I would certainly imagine in larger medical device organizations, say, like, I don't know, Johnson & Johnson or Edwards Scientific, or, these really, really big organizations, there is probably a lot of that where you have siloed development. You have the mechanical department and the electrical department and the firmware department. They probably, a lot of companies don't form these product development teams where you have a cross-functional group working on a single product line. Yeah, I imagine it is a real issue. So
there's another question that I've been meaning to ask, because now you've persuaded me that, okay, DevOps works for embedded systems, works for hardware adjacent products, I suppose, or products combining hardware. But now you come from an even maybe more difficult world, which is the world of medical devices, a regulated industry, a safety critical industry where you can't just do whatever you want and iterate whichever way you want and then looks good, let's deploy it, and then somebody's pacemaker fries, and that's like not a good thing. Does Agile work in safety critical environments in regulated industries?
Yes, it does. There's it's a hot topic in medical devices right now, and the FDA has issued guidances on this, and there's been technical information reports that kind of try to clear up this misconception that agile development is incompatible with being safety critical. Trying to get concrete, as I like to do, the way that the things that separate, say, regulated industries or safety critical industries from those that are not so. Fundamentally, it's risk analysis and risk management. So like when you say, you're putting a pacemaker in someone, and if you make a mistake, it could kill them. Essentially, the way that you do that is, you first come up with this concept of this pacemaker, how it's technically going to work, how are you even going to regulate someone's heartbeat? And then you very methodically and thoroughly think of everything that could go wrong and the probability that it's going to happen and the severity of what it does. And then you introduce additional requirements into your engineering requirements into your system to mitigate those risks and to bring them down to an acceptable level. And, the FDA in particular for medical devices gives you this high level process to accomplish that, but they don't necessarily specify the details. That's up to your company. But that's what you need to do to produce a safety critical device that's not going to cause harm to a patient. You can still do that in an agile context. I would say the difference is that what you think of as a sprint, where you actually release a device to a customer, there's going to be internal product development sprints. But if you think of an overall iteration of, you come up with a concept and you clear it past the FDA and you put it to market, that broadest definition of an iteration, that will be slower than, say, a web development project. But it still can be a lot faster than it has been in the past. And essentially you do that by really being ruthless with the number of requirements that go into that version 1. And then you still have to do all the steps. You still have to do the risk management. You have to specify requirements for each of the engineering disciplines. You have to verify them on the back end. You have to validate the device. But going to market with a truly minimum viable product absolutely works in that context. You just have to follow all the steps. You don't do this multi-year development effort. You can do it in 1 year. It still may drive people nuts that you're not maybe people in your audience that are used to much faster iteration times, and you can still do those very fast iteration times within the product development cycle. Like as you're actually writing the firmware for your device, you can realize, it's not going to work the way that we think it was. We need to change, and you make that feedback loop as fast as possible. But your overall iteration, you can certainly cut from years to a year.
But that still sounds to me like you have some kind of a waterfall start to the process anyway, where you do your safety analysis and you write down your requirements. Like in the bad old days, you write it all down upfront and then you pass it on to the developers and they, do their thing. Is that really what's happening, or do you even iterate on like your safety case and whatnot?
Absolutely. Yeah, you certainly iterate on the, even within that shortened product development cycle, you certainly iterate on the requirements, you iterate on the risk management, and you need to set up your tooling. And so at that point, it's when I say tooling, at that point, it's no longer just the engineering tooling, your continuous integration server thing, but it's the software that you're using for requirements management, the software that you're using to manage test cases and link the two together to verify that all your requirements are actually tested. Those tools need to be set up to support this rapid iteration of requirements. And that is where the medical device industry is way behind. And a lot of people are still writing Word documents and Excel files to manage these things and linking them by hand, which is horribly error prone and takes a long time. And so that's great if you write it once and never change it, but as we all know, it changes constantly.
So you should automate Excel.
Automate. Well, so if you didn't have any other tools available for you, yes, that's what you should do.
Okay. But it was just a joke.
Right. There are requirements management tools that make this possible. And what you should automate is the creation of documents. So in the end, there needs to be a PDF that goes to the FDA that lists out all your requirements and lists out all your test plans and shows the results of running those individual tests. Those documents, the production of them from this tool that you actually work in, you absolutely should automate the production of those documents rather than working in Word directly. Because then as those inevitably change over the course of a project, you don't have this parallel effort of trying to keep them up to date. They're kept up to date naturally. And linking all of the wonderful things that databases enable behind the scenes can be automatically reflected in your documents.
And that's something really interesting that I think is worth pointing out, that you have to modernize not just and make Agile not just your product development in terms of maybe code, but also really the requirements management side, because traditional Agile, quote unquote, maybe is fairly light on requirements management. You have a bunch of user stories and you keep them in a backlog, and that's it, essentially. Like there is no tracking, there is no, what's the word? I'm blanking on it. Traceability. But of course, the FDA requires these kinds of things. So you have to almost separately agilize, it sounds like, the requirements engineering side of your product development.
Absolutely. Yeah. So the regulatory and quality teams in, say, a medical device company need to get on board with this. And it's funny in my work, I know a lot of medical device quality and regulatory people. One woman I'm thinking of in particular is extremely competent, extremely well-knowledged, and she hates Agile because teams that she's worked with in the past that have said they were Agile used as an excuse to not do the necessary work. They used it as a crutch to basically say, oh, we're Agile, we don't actually need to write requirements, or we're going to take our Jira user stories and just kind of like we're literally print it from the screen, and the format is completely unsuitable. It's not useful for anyone else. So they're not thinking. The problem is the development team she's worked with weren't thinking from a system perspective, because in medical devices, the system includes generating documents that are going to be read by the FDA. You don't get to sell a medical device without them. So it's a necessary component. You can't say, oh, we're Agile in our development process and we've made this device in half the time that we used to, or whatever. It does no good if you can't get it past FDA and sell it. I told her recently, I can't wait for the two of us to work on a project together so that she can see how good Agile documentation can be. And she said, great, can't wait. So when we do finally work together, I'll have to put my money where my mouth is.
Yeah, that's interesting. Like this is something that I also encounter in other contexts quite frequently, that, your idea of what your product constitutes needs to change. Your product is not just the widget that you build. It's not just the pacemaker. It's also the documentation for the FDA. And so you also need to, as you hinted at before, you need to create that in an Agile way.
Correct. And recognize, so the problem is that people, because they still have this waterfall mentality, they don't invest in improving that tooling or that process. And so then changing it is a real pain. It's full of a lot of friction. And so then they do that classic vicious cycle where then they don't want to do it as often. And that's, sends you down this road path of very waterfall based development when it's just not real. Whereas we all know that, if something is painful, do it more often. So if it's painful to update your risk management and then update your requirements and then update the traceability matrix, automate it so that it is painless, and systematize that process so that, every time, oh, I just thought of something that needs to change in our risk management, like from that aha moment to the documentation is updated. And that not just for the documentation's sake, but that as an engineering organization, you've done your due diligence and you are confident that your device is safe, that you have not introduced any risk, or that you have mitigated any additional risk that you've introduced. You satisfy yourself first and then satisfy the FDA. Anyway, from that aha moment of realizing something needs to change until it is actually changed and is ready to go to the FDA, that you need to smooth and automate as much as possible. And a lot of people just don't go through that effort.
Sometimes I think automation is even a question of mindset. If I look to my customers, I think I see the younger guys. They are too. I don't know the English word for faul. Luca, kannst du mir kurz helfen?
Lazy.
Lazy. They are too lazy to do the second thing again. So they automate it, and the older people. They are not too lazy. It's work for them. They are busy, and so maybe it's a little bit black and white looking. But what do you think? Do you see that too?
It's interesting. So I've often heard that software developers do all this investment because they're lazy and they don't want to keep doing things. And for the easy things, that's true. But when automation requires a fair amount of investment, I don't think that whether you're lazy or not will determine which way you go. It's having that faith that, like, sometimes automation requires an investment of effort. And if I'm lazy, I'm going to avoid doing that, in one sense. So, so that making that short-term sacrifice for long-term gain, cutting your development velocity down in the short term, knowing that in 3 months it's going to be much faster. That takes a certain amount of forward thinking and faith that process is going to turn out, and it takes a management and leadership team that's going to support that. Either they have faith that it will pay off, or they've created a culture where occasional failure is okay. That a culture of experimentation. We're going to try this, and maybe this specific effort won't pay off, but overall, the fact that we as an organization are experimenting with new ways to improve, that will pay off. So it's funny. Yeah, I've often heard the lazy trope, and I think it's very it applies to things that require very low investment. Then your laziness will clearly drive you to make that quick win and that quick script. But when something takes more time, it's I don't know that that's the best way to think about it.
Yeah, that's the thing, right? Also with technical debt, for instance, in general, and I suppose you could talk about automation in terms of process debt. You're trading future velocity for present velocity. Right.
Yeah,
absolutely. If you have that, go ahead, Jörg.
No, it was just one remark, because if I'm working as a coach, it's not very cherished to say you are lazy. So just a small footnote.
Got it.
So, but I mean, you are making a very compelling argument for why Agile and DevOps really should be in every engineer's and every business's best interest. And it should really be, I suppose, the industry standard. So why isn't it? Or is it? I don't think it is it?
Sir, again, I can only speak to the medical device industry, but it's certainly not there, though it is becoming more accepted. There is more and more talk about it. There's official guidance document, which, a lot of the legacy companies kind of always look to. There's now official cover from the FDA to allow them to pursue this. Though I will say, another way to divide up maybe the audience or the people who have to actually handle this in real life. There's more established companies that maybe have a suite of products or quite a few different product lines, and they're coming out with new versions every few years. And then there's startups who spring into existence solely for the purpose of releasing one single product, and they're just hoping for an acquisition. Those startup teams that are they're often, sometimes none of them are full-time employees. That's actually a project that I'm working on right now. It's the two founders and a bunch of consultants. These teams that spring into existence for a single purpose and then disband, they are going to have a harder time applying DevOps principles because the organization as a whole has less time to continuously improve. You can think of a larger organization that really believes in these principles. They're going to learn from one project and apply it to the next, and then apply it to the next. And yes, even within each project, of course, they're continually improving. But sometimes some lessons aren't learned until the end of the project.
And I think that's not my way of thinking of agile or being agile and DevOps, because you have to build up teams who are working for a long time together.
Right. That's where you're going to get the most wins, is where your team has time to continuously improve. And in the embedded world, and especially in the medical device world, there are startups that are literally only together for 3 years before their technology gets acquired by a larger company, and off they go. And so there's just not a lot of time there to really improve. And so that's, as a consultant, that's the kind of project I'm involved with. And so I bring in, I'm working on applying DevOps to my own work. But in terms of coming into an organization and really affecting change at the organizational level, it is much more challenging. And sometimes I just can't do it. I have to work within the constraints of the organization I'm in. And there's not that time to, say, build that credibility to then leverage it into organizational change. Luca and I, not too long ago, talked with a man named Joe Schneider. He's runs a embedded consultancy here in the States. But for a long time, he worked for John Deere, which is this agricultural company. They make tractors and agricultural equipment. Think of a legacy company. But he was with them when they started their agile transformation of their firmware development group. And this was a large company, and there were 400 firmware engineers by the time he was done. And it took, he was there for 10 years. And over that time, the organization as a whole made huge improvements. And they started with this little kernel of technical practices and slowly over time transformed that into, or that evolved into an organizational transformation. And if you're a startup, you just may not have time to do it.
Yeah, that's actually an important point to make, I guess, that there's just so much more to think of in embedded systems than in quote unquote ordinary software work, because you have all the challenges of software, plus you have the challenges of hardware, plus you have the challenges of documentation, of regulation, potentially anyway, plus you have the challenge of not being able to continuously deploy your code. Or at least I would feel a bit uneasy about over-the-air updates for pacemakers. Is that actually a thing?
So not for pacemakers. I would say so the FDA kind of has different risk level classifications, class 1, 2, and 3, and pacemakers are class 3, which meaning that they could cause severe injury or death. Class 2, which is they could cause moderate injury, or class 1 is minor or no injury. Class 1 is a Band-Aid. Class 2 is a diagnostic device that's returning a diagnosis or some kind of treatment device that is not treats your eye maybe or something, but is not life critical. So certainly medical IoT is also a hot topic, and people are doing over-the-air updates, but I imagine they are not doing over-the-air updates of pacemakers. For that, because of that risk analysis, the risk is that something goes wrong and someone dies, and there's really I can't think of a strong way to mitigate that. Maybe you could, and if you can, then by all means. Like a long time ago, we talked about Tesla, and I don't want to open a can of worms talking about Tesla too much, but they do over-the-air updates, and they have done over-the-air updates of things that are safety critical, like the suspension performance and the ride height. If they got that wrong, they could cause a lot of crashes. So they, I hope, behind the scenes went through a process to verify that to a level where the risk was low. I think, the can of worms is that their risk tolerance is higher than a lot of us are comfortable with, but that's all I'll say about them. But you're absolutely right. I mean, not over-the-air updates are rare in the medical device industry, and that makes you less agile as an organization because it is more difficult to iterate on your product after it's out in the market. You have to release a new version, and then now you're dealing with the headache of configuration management.
Yeah, and also maybe you need to cut open your patient to install the new version, which is kind of a bummer.
Right. So that's the kind of thing where when you can't do updates of your product in the field, you have to, and I'm advocating to release a minimum viable product. Like, you release a pacemaker, it needs to work as a pacemaker, and then maybe the next year you introduce an improved version that maybe a pacemaker is a bad example, but is a better pacemaker in whatever axis that is. And, new patients are getting that, and that's based on feedback from the initial cohort of patients. But they still have a safe and effective product. Maybe your new pacemaker implements new functionality, has additional requirements that are based on market feedback. Again, pacemaker may not be the best example, but we'll run with it.
All right. That, I think, has been very, very interesting. Dirk, are there any questions you would like to to ask of Jeff?
Oh, no. Just for the second, no. It was a really it gave me a good impression for the problems you have or the issues you have using Agile, using DevOps in those kind of industries. And I hardly have no answer for that, because my last question may be, you say hardware is you have have a longer sprint. How much would you guess that a sprint in hardware development is?
That's an excellent question. Luca and I have discussed this previously. So I would say typical is several months. So say you're developing an embedded device and you discover a problem that requires a hardware fix. I would say typically you get a bunch of those problems to stack up, and then they're all fixed because this is people not leaning into the pain of what's difficult. They let a bunch of those things stack up for a few months, and then they do a big revision, and that process of, once we say, okay, these are the things we're going to fix, it'll be 4 weeks minimum until the board is delivered. But it is so common to wait on those kind of things for months. And Luca has proposed to me in the past, and I'm certainly intrigued by the idea of having essentially a fixed hardware iteration where, yes, okay, whatever time from you start the new schematic, which then leads to new layout, which you order the boards and you have them delivered, whatever that iteration time is, becomes your hardware sprint, or maybe something just barely bigger than that. So that actually you have a new set of hardware coming out every 4 weeks or 6 weeks or whatever it is. I have never seen that done. I am intrigued by the possibility. I think it could be really, really powerful.
Sounds good. Thank you.
You're very welcome.
All right, Jeff, I think this is an excellent place to leave it. Thank you so much for being on the show. Where can listeners find more about you? And this is something maybe you would like to brag about.
Sure. So you can just go to my website. It's jeffgable.com. That's JEFFGABLE.com. And you can also find me on LinkedIn. Obviously, all my content and writings are in English, not German. But and you can also, Luca, you and I obviously have another podcast called the Agile Embedded Podcast. And if any of you out there are interested in learning more about how Agile techniques apply to the embedded world, I definitely recommend listening to that podcast. You can find it on any major podcast publishers, Apple, Google, Spotify, etc. So the Agile Embedded Podcast is what you would look for.
Awesome. Thanks so much, Jeff. So again, thank you again for being on the show. This was a really fun and interesting episode.
Thank you.
Thank you so much.
Thanks, fellas.